Hello again, CHS, here for another virtual lesson. So the last couple of lessons we've been talking about exponential growth and decay. And so we did those as graphs, then we did those as a model, and then we went into a little bit of compound interest, which is similar to exponential growth. There's just a little more factors to it. So now we're going to continue on with some exponential knowledge. It's actually the second part of this section. They're really not related that much, but again, it's all exponential, so that's how they're related. So now we're going to talk about how, if I give you an exponential equation, how to solve it. There's actually a couple ways to do it. We're just going to talk about one way, and that's when you, for the most part, have something that has an exponent of x equal to another thing that has an exponent of x. So we're going to go through that process now. Again, the biggest thing to remember with exponentials, any type of those, what makes an exponential is the variables and exponent. We're still solving an equation just like we did before, trying to solve for x, but the unique thing is that now x is in the exponent, and so that creates a little bit more of a thing that we have to fix before we really can solve for the exponent of x. So in order to work with that, everything has a property of equality. A lot of times you would have gone through those in Algebra 1. This is a new one. So the property of equality for an exponential equation, like I said, since there's really two parts of an exponential equation, you have the base, the big number that has the exponent, and the exponent has an x. So there's two parts, the base and the exponent. So in order for us to be able to use or solve these equations, in order for the property of equality to work, the base has to be the same, and the exponent then can equal one another. So for example, here's a kind of a basic way to look at the property of equality. So if we have 3 to the x and 3 to the 5th, since both of their bases are the same, that means that the exponents then can equal one another. So as long as these two bases are equivalent, the exponents can also be equal to one another. So in this case, x would equal 5. Now for our problems, there's going to be a little bit more going on to it. Both of the exponents can have x's. There can be other numbers along with the x. But again, and ultimately, in order to solve an exponential equation, both these bases have to be the same. So what happens when they're not? Well, for our cases now, what we're going to look at are equations where the bases may not start off the same, but they're related. So what we can do is kind of do a little bit of an adjustment on our base and then make it so that we can solve the equation. So how we can do that adjustment is typically you're going to have two bases. One will be a smaller number, one will be a bigger number. What we can do is we can take our bigger base and adjust it down to match our smaller base. You can't adjust up because then we're changing the answer, but we can adjust down because we're just kind of doing some substitution, swapping something out for something that we started with. So like instead of having a 3, if we had a 9, well, 9 is 9, but another way we can get 9 is 3 to the 2nd power, which is related to 3. So we can adjust down using exponents. So that's why we can always have to adjust down, because 3 squared is 9. But if we try to change the 3 into a 9, then you're trying to change the number, so you can't do that. So you only can adjust down to make the bases match. So let's go through that a little bit more. Hopefully that'll make more sense when we go through the example. So that's ultimately what we're going to end up doing. So we're going to go through a variety of examples. So some of them are going to be set up ready for us to go. We won't have to worry about adjusting the base, and then some of them we will have to. So if you look at this first one, we have 15 to the x plus 1, and it's equal to 15 to the 5x. So the first thing you have to check, are the bases the same? And in this case they are. So if that happens, we don't have to worry about adjusting the base at all, but what we can do is, since these two things already are the same, what we can do is take their exponents and set those equal to one another. Because if the bases match, then the exponents have to be the same. That's just how that property of equality works. So we can take the exponent down. Basically, once you have the base the same, you can kind of ignore it. So you can take the exponents down and create a little equation for ourselves to solve. So like I said, most of the time there's going to be a little bit more than just x on one side and a number on the other, like my little property had. So here we have x plus 1 and equals 5x. So once we have the bases the same, it really turns into a linear equation that we solved back in Algebra 1. So we need to get the x's together and then get x by itself. So what I'm going to do is, since we have x's on both sides, I'm just going to take this single x and move it over to 5x. So I'm going to subtract the x over here. So I get 1 is equal to 4x. And then we're going to get x by itself. So I'm going to divide by 4. And I'm just going to leave it as a fraction, so x is 1/4. And there's the first example. Like I said, that one's a little bit more straightforward. We usually try to start with more straightforward examples and then go from there. So those bases were already the same, so you could go right into the exponents to solve. So you don't have to worry about adjusting any of the bases. And then once you get to the exponent solving portion, it's just like any other equation that we've solved before. So this first example. Let's do another one. So again, here we have two exponential equations, or two exponential expressions. We have 3 to the x minus 4, and that equals 9 to the 2x plus 3. So both of those are exponents. So these, for this example, those bases are not the same. So we can't just start with setting the exponents equal to one another because their bases aren't the same. So what we need to do is we're going to adjust this bigger base, this 9, down into the smaller base. Now we don't do that with we don't do that with multiplication. We have to work in exponents. So you have to think, if I'm going to adjust the 9, I know I want to adjust it down into a 3. So go ahead and adjust that. So then I think, okay, 3 to what exponent equals 9? So then that's where if we get into some other ones you don't quite know, you start using your calculator to help you out. So 3 to what exponent equals 9? Well, 3 to the second power equals 9. So what I can do is you can swap out this 9 for 3 squared, because 3 squared is 9. So we're just changing the way it started off looking with something that's the exact same. It just looks a little bit different, because 3 squared is 9, 9 is 3 squared. So you can do that kind of as a substitution. So we swap this out for something that's equivalent to what it started with. That's what makes this process able to work. And then it's going to match the base that's on the other side. That's what we need in order to be able to solve an exponential equation. We need these two to be the same. So then once we've adjusted that, the other thing we have to look for is, did 9 already have an exponent? Which it did. So what we're going to do is just combine those two exponents. And you can just take the 2 and we're going to distribute that in. I'm not going to show that right on this step, so I'm just going to put it next to it. So once you adjust the base down, the new exponent that you came up with, just multiply that with the exponent that was already there. Okay. Every once in a while we'll work with something that didn't have an exponent. If that happens, then your exponent's just going to be 2. But since 9 already had an exponent, just take the exponent that we came up with to adjust this base down, and you're going to multiply it to the exponent that's already there. Okay, and like I said, I didn't show that just yet. I'll probably do that on the next step. So don't forget that if there's multiple things there, the exponent that you came up with has to distribute to both sides. So that's going to change to 4x and 6. Now you'll see that on my next step. So now, just like with the first example, now our bases are the same. Okay, so up here their 15s are the same. Now they're both 3, so I can take their exponents and set them equal to one another, because if the base is equal, the exponents have to equal. So I can just get rid of the 3 now, drop down its exponent, get rid of the second 3. Now like I said, with this one I'm going to go ahead and show the distributing. So that's going to become 4x plus 6. So I distributed that 2 into it. So we got the 2 is the one we came up with to adjust the 9 down. So we adjusted the 9 down to a 3 squared, because 3 squared is 9. Okay, so we swapped it out for something that equals it. And then the 2 we came up with just multiplies to the exponent that was already there. So that's why this became 4x plus 6. And again, it's always adjust the bigger base down to the smaller base. So the 3 stayed the same. The 9 changed to a 3 squared, and then we multiplied it with its exponent. Now once we get to here, like I said, it's just going to be an equation that we've solved in the past. So I'm going to get my x's together and my numbers together. I like moving it so that x is positive. So I'm going to subtract this x over here with 4x. Okay, and at the same time, I'm going to go ahead and subtract 6 over with 4. So I got negative 10 equals 3x. Okay, and they won't always be fractions, but they do work out that way a little bit sometimes. So I try in my examples show that. So here I need to get x by itself, so I'm going to divide by 3. I'm going to go ahead and leave that as a fraction. If you want to divide out as a decimal, that's okay, but no sense in using your calculator if you don't have to. So I got negative 10 over 3 equals x. There's my second example. Again, the first example, bases already matched. So we just had to set the exponents equal to one another. The second example, the bases didn't match, so I had to adjust the bigger base down to the smaller base. And then we use the exponents to do that. So 3 squared, 3 to the second power is 9. Then took that 2 that we came up with, multiplied it to the exponent that was already there. So that's why it turned into 4x plus 6. And then we solve for x. So we're going to do just a few more. There is a couple times where, like I said, sometimes both of them don't have exponents, which is okay. We're going to do an example like that. And there's actually sometimes where there's not a direct relationship between these two, so you might have to do a little bit of adjusting on both. So we're going to talk about that on our next 2 examples. Here's the next one. So we have 4 to the 2n minus 1, okay? And then just equals 64. So 64 doesn't have an exponent, and that's actually okay. If you really want to, everything has an exponent. You could put an exponent of 1 here, but it's not required. But so we're still trying to get it so that we can solve for that exponent, okay? So the only thing we can do is, again, adjust that bigger base, the 64, down into the smaller base, the 4. And then, like I said, sometimes you can't do that, and we'll talk about that more on the next example. For this one, I just wanted to cover sometimes they both don't have to have an exponent. Just one of them could. So we're going to take this bigger base, this 64, we're going to adjust it down into a 4 if we can. So again, if you're not entirely sure, exponents of 4 squared, probably know that's 16. But after that, we haven't really worked a ton with exponents as far as that case. So we can figure out 4 to the 3rd power is 64. Okay, so I just typed in my calculator 4 and then my exponent key and then 3, and I got 64. So I know I can adjust the 64 down into a 4 to the 3rd power. Again, we don't have to worry about any existing exponent with 64, so my exponent is just the 3. But now I have my bases matching. They're both 4, so I can take their exponents. Since I now know that the bases are the same, the exponents have to equal one another, so I can take it and solve for that n. Add the 1 over. So that 2n is equal to 4, divided by 2. So n will equal 2. So there's a 3rd variety. Yeah, there's really 4 different variations. That's what I'm going to show you 4 examples. So the first one, the base is already matched. The second one, I could adjust the 9 down. 9 already had an exponent, so we had to multiply it to the exponent that we came up with. 3, they don't both have to have an exponent to start with. So if you just have a solid number, you can still adjust that down into the smaller base. So we have 4 to the 3rd power, we can adjust it down and then do the exponents. And now the 4th variation is where they're not directly related to start with, and so we might have to adjust both bases. They look like they might be related, 4 and 8, but really there's no exponent you can make 8 into a 4 using exponents, okay? Because 8 to the second power right away is 64, okay? Oh, sorry, 4 to the second power right away is 16. Sorry, we're adjusting down. So we can't do that with the 8. We can't make it a 4 using an exponent, because like I said, 4 squared right away is 16. So that goes right above 8. So what we can do is adjust them both down to a smaller base. And so a smaller base that would be related to this, I'm thinking 2, okay? So we have 2, because that's a nice even number, both of those are even. So a lot of times when you end up having to adjust the base down, usually it's to 2 or 3. So we can think of it as far as exponents. So 2 to what exponent is 4? That's 2. So 2 to the second power. And again, just multiply it to the existing exponent. So next time, just multiply by 5x. And then 2 to what exponent is 8? Well, 2 times 2 times 2 is 8. So you have 2 to the third power that I can adjust my 8 down into. And I'm going to multiply it to 2x minus 1. So again, I had to adjust both of the bases, because again, I couldn't adjust 8 down into 4, because 4 to the second power is 16. So that went right over 8. But I could adjust both of them down into 2, because 2 squared is 4, and 2 to the third power is 8. Okay. So again, now that I have the bases the same, I can take their exponents and multiply them together. Oh, sorry, I set them equal to each other, but I have to multiply the exponents that was with the exponent that I came up with. So the 5x is going to turn into a 10x, and the 2x minus 1 is going to turn into 6x minus 3. So make sure you do distribute if there's multiple things. That's a 10. And then we solve for x. So I'm going to subtract the 6x. We got 4x is equal to negative 3. And again, I want to get x by itself. So divide by 4. So then x is going to equal negative 3/4. So again, there's 4 varieties of equations. One where the bases were already the same. One where you just had to adjust one base. And then there was an existing exponent you had to multiply by. One where you have to adjust just one base, but there was no existing exponent. And then one where you have to adjust both bases. So I hope this made sense. If you have any questions, just let me know. You email me. Feel free to rewatch this as many times as you need. And then there will be a little assignment involving all 4 different types. So thanks for watching.